Hello and welcome to Skynet Today's Last Week in AI podcast, where you can hear us chat about what's going on with AI. As usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. You can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I am one of your hosts, Andrei Kurenkov. I just got my PhD degree from Stanford, where I studied robotics and AI, and I'm now working at a AI startup.
And I'm your other host, Jeremy Harris. I guess I have last name too. I do a bunch of AI safety stuff, focused especially on like catastrophic risk and that sort of stuff. And I am only the second most interesting co-host whose name starts with J, who's going to be on this episode, because I'm super excited that we have right here with us in the digital flesh, John Crone, who's the host of the Super Data Science podcast, which we were just talking before we started recording this episode about how podcast hosts are notorious for not listening to podcasts. I actually have listened to, I'm the hypocrite here. I've actually listened to his podcast quite a bit. I'm a big fan.
You hypocrite!
Damn it. One of the things that I really love about it, he's got these people who've done cutting edge research, like OpenAI people, Microsoft people. He talked to one of the key authors on the GPT-3 paper and so on. So anyway, I'm going to let him plug his show here. But John, thank you so much for joining us. This is just an absolute pleasure.
It is my honor, truly. I listened to Last Week in AI religiously. So following on from that hypocritical comment from Jeremy, I also, as the host of a podcast and lots of other balls in the air, so I'm also a co-founder and chief data scientist at a machine learning company called Nebula, where we're reimagining the future of work through AI, particularly generative AI, believe it or not, lately. I wrote a book, Deep Learning Illustrated, that was a #1 bestseller. I create lots of videos for my personal YouTube channel, but yeah, probably the thing that I'm most known for is the Super Data Science podcast. So we have 2 episodes a week, every week of the year. So 104 episodes a year. It's quite a grind. And on top of that, I don't really have time to listen to podcasts. Like since the pandemic, I've been working from home all the time. I don't have a commute. I moved into an apartment building where my gym is across the street so that I didn't have to like worry about losing time there. So I hadn't been listening to podcasts, which, you know, again, to Jeremy's hypocrite point, it was kind of awkward because people often ask you like for recommendations. Right. And I'm like, I have no idea. I've heard of Lex Fridman. Maybe check that out. I never really listened to it. Though I know Jeremy has at least listened to that because he can do a really good Lex Fridman impression.
Not on the air, John. We said not on the air.
But yeah, so Jeremy's been on 2 episodes of the Super Data Science podcast. So he had one long episode that kind of introduced him in 2022. And in that one, it was an amazing experience for me in general, because Jeremy and I talked for 2 hours before we started recording. We recorded a 2-hour episode and then spoke for another 2 hours immediately afterward. And in that episode, we obviously talked about the AI policy stuff that Jeremy focuses on. So then when GPT-4 came out earlier this year, I quickly scrambled and I was like, who can I get? Like I had a trilogy of episodes. So I did one myself where I was like, GPT-4 is here. And then I had someone come on to talk about the commercial opportunities of GPT-4, but I wanted someone else to be able to talk about the policy issues and the risks. And so Jeremy was the first person who came to mind. So that's episode number 668 of the Super Data Science podcast, if you want to check Jeremy out there. But the reason why I mentioned all of that is because in that show, I was like, oh, and he hosts the podcast that he used to host. I don't even need to name it now. And Jeremy was like, actually, I don't do that show anymore. I'm on this show called Last Week in AI. And I had a laugh because with Jeremy doing all of his existential risk stuff, I was like, is it called Last Week in AI? Because this is like the final week of everyone on the planet. This is like the last week. The final week, thanks to AI, brought to you by Skynet Today. So Jeremy told me about it. And because of how much I enjoy speaking to Jeremy, I was like, well, I'll give it a shot. I'll find a place, like, so now it's like when I'm shaving, when I get out of the shower, I like just put I listened to Last Week in AI, and there manages to be just enough time in the week to listen to the whole show. And I've listened to every single second of every single episode since you were on the show in April. I never miss it. And I'm a junkie for it now.
Wow. I didn't know it was that addictive.
It is. And so you guys it's quite a different show from Super Data Science. Like Super Data Science is an interview show. You have guests on, they talk about their specialization. You get quite deep in the weeds for an hour and a half, typically. With you guys, it's a completely different kind of experience that is so valuable to me as a data scientist, because you cover all of the big news, all of it. You manage to jam it all into 2 hours, and it allows me to then go into any meeting, whether it's with my data science team or whether it's with a non-technical stakeholder. And previously, sometimes I would get caught off guard by people being like, oh, have you heard about so-and-so? And I'd be like, no, like you can't keep on top of everything. And now I'm actually on top of everything all the time, thanks to YouTube.
This is so funny. I had no idea why anyone listened. But this is good to know.
Yeah, John, maybe you should write us a quick Apple review just so everyone knows.
Well, you know what though? I think these sorts of shows dovetail nicely into each other, right? I mean, there's a lot of times where you get a big, we don't have time to go into like the details, the weeds on how exactly, Llama 2 works or whatever. We do that like 5-minute conversation, but I think that's where the deeper conversation comes in. And if you're going to listen to that, I do want to say, I think Super Data Science is the place to go for it, because you are a gifted interviewer. I can say this in a very unbiased fashion, but it's true. Like, I mean, I think I told you after those conversations, they were sort of like the deepest and most expansive that I've seen compressed into 2 hours of time, which I never succeeded at doing in my previous podcasts.
All right. So that was fun hearing how our podcast is awesome. And I think this will be really fun. Yeah, we haven't done a free host recording in quite a while, so let's see how this goes. I think the most recent one was actually Jeremy was a guest on this podcast back when he was not a co-host.
True. Weird, yeah,
with Sharon. So
I'm coming for your jobs. I love this show so much. I need to be in it.
Well, before we dive into the news, just a quick segment with the response to listener comments and corrections. We had one cool review on Apple Podcasts from CBKOK Han. I never get tired of reading these usernames. And they just said, awesome podcasts. So apparently people do agree with you, John. And we had a couple comments also regarding us discussing things that we're not experts in. Some people said, well, do keep discussing kind of legal implications that just flag that you're not experts and you may be wrong. And I think that is probably what we're going to keep doing anyway. We're just going to keep making stuff up about medicine and legal stuff and speculating.
We did get rid of the stock tips section at the end of the podcast, so we will be putting that on hold.
No financial advice from now on, except that you should invest in NVIDIA, obviously.
Yeah, definitely NVIDIA. Invest in NVIDIA.
Well, let's go ahead and get going with news. So first up, we have tools and apps. And the first story there is Google's AI-assisted note-taking app gets limited launch in NotebookLM. And that's the story. There's this NotebookLM that Google launched in a limited capacity to a select few users. It's designed to help students organize their lecture notes and other documents. It can analyze and answer questions about the documents. It is aimed to kind of reduce hallucination and false stuff. It's still an experiment, so it's not really anything big, but it's one of these things, kind of a smaller scale project. And I think there probably are many similar tools out there. I know there are tools to sort of like ask about the PDF, you give it a PDF, you can ask questions about any document. This seems to be sort of in line with that.
Yeah, it definitely is interesting as well where this lives in the workflow. Like you could see this being potentially like an integration point or a play for an integration point between many different tools. So, I mean, I was curious about where the value is going to end up aggregating in the AI stack. You look at student populations, where are they going to spend a lot of their time? Well, taking notes is probably a big thing. And, if there are secondary tools you can fold into that, this could be one of those like value accretion points. But yeah, other than that, it just seems kind of interesting.
Yeah, I think from an academic background, this makes me think of there are tools, I think, similar to this, where you can upload a PDF and talk to the PDF essentially. And if you're reading a paper, right, you can imagine how this sort of thing would be useful, where, maybe you just want to upload the PDF and then like answer the questions you have immediately without looking for the information, get the AI to read it for you and let you know how, what the answers are essentially, and hope that it's not hallucinating. And hopefully this whole effort to make sure that the answers are accurate, which it supposedly does by restricting itself to analyzing and answer questions via the document, while still drawing on some of the broader knowledge, is it's nice to have something like this as opposed to just like copy pasting everything from a given document into ChatGPT and then asking questions about that. Have you played around with any kind of AI tools for your own workflows, John?
Oh yeah. So GPT-4 is my big one. I'm using it every day for such a wide range of tasks. It's one of the most mind-blowing things for me has been how quickly it allows me to create tutorials. So I teach people how to do hands-on with hands-on code demos, and it is mind-blowing. I can now prototype things where previously I was having to dig through Stack Overflow, and it wasn't exactly the right library version, so it wasn't exactly the right solution, and easily losing half an hour or an hour just with random little errors. And now I just copy and paste everything into GPT-4, and it's like, oh yeah, so let's just rewrite it this way. I can see why you did it that way. Great job, John. But you could just do a tiny, just keep on trying, and we got these tiny little tips for you will make your life a little better.
What's your relationship like with hallucinations in that context? Do you run into them a lot? Is it like how much of a pain are they?
Never. I never encode ever. And it's interesting for me. One of the things that we talked about when GPT-4 was coming out, and you were on the Super Data Science podcast, Jeremy, was we were talking about how, like they cited specifically how the hallucination rate had gone down by some double-digit percentage. But the thing for me that I don't get where that percentage came from, because for me it's night and day. Like I went from with GPT 3.5 feeling like I needed to double check everything, and now I'm in this really dangerous scenario with GPT-4 because I never need to double check things. That in the odd instances, I guess, that it does hallucinate, I'm not checking. I'm not submitting like legal documentation to a court. I would definitely recommend
all our legal advice on the show. So
yeah, well, we, since moving to this ChatGPT like bullet point node generation system, we do read the articles and try to make sure we don't say anything false, but some of the bullet points might be hallucinated. So we basically rely on the listeners to tell us if the AI has led us astray. So let's hope that is minimized. But I'm pretty sure it's fine.
Yeah. So it is amazing. I think this hallucination thing is becoming less and less of a problem all the time. And I know that there are companies out there that specifically provide tools that allow you to vet for these kinds of things. So a company based in New York, I know the CEO, this company called Arthur AI, they've developed what they call the world's first firewall for LLMs that is looking out for a whole bunch of things like misuse of LLMs, but also for hallucinations. And so it's as quickly becoming, as you guys often talk about the show, it's one of those things that a year ago seemed like this insurmountable problem. And now a year later, it's like, wow, it's not that big of a problem at all.
Yeah. And it is true also that, like, depending on the task, hallucinations can be more or less of an issue. Like if you're, for example, doing summarization and you're actually loading a full like article or something in the context window of the model, then you're much less likely to encounter hallucination just by virtue of how much of an influence it has on next token prediction. But then like if you're just asking it zero shot, like, hey, what are some facts? Much more likely to hallucinate. So yeah, it's such a weird variable landscape, and like how to develop calibrated trust in these systems, I have no idea.
And on to the next story. artists are losing the battle against AI. Glaze, a tool that's found a way to trick algorithms, is giving them a fighting chance. So this is about a team at the University of Chicago that has developed a program called Glaze that can protect art from AI by cloaking the images with some very slight alterations that are not generally perceptible to humans, but actually do make a big difference for AI. And this program has apparently been downloaded over 890,000 times since its release in March. And we've already talked quite a lot about how many artists are concerned about AI, and there's been a lot of response and discussion. So what this program does is it can sort of watermark or mess with your images a little bit, so that if someone does try to get your images and train a model on those images, as has been done with Midjourney and many other things, then you can sort of protect your own art in a sense that you create and post online. It does sort of kind of a known trick in a way of it's been shown for many years that AI models can really understand images way differently if you just add these little tiny changes to the RGB values in some way that humans cannot see, but somehow does mess with AI. So that's what it looks to be doing. I'm not too sure how this plays into a training. Usually that's been done for the classification or the perception part of it. But still, I think this is interesting to find out about.
Yeah, I think it's a lot like the preceding story where this was something that it seems like regularly on Last Week in AI. It's like I'm hearing, all your data are being taken away, copyrighted data issues. What are we going to do? And then boom, all of a sudden, 1 week later, 800,000 people have downloaded a solution.
Yeah, and the short cycle times, the short lifetimes of companies and products that this implies too, right? Like you have problem, solution, and this company, I mean, there's going to be a way around this eventually, because this is basically a kind of adversarial vulnerability that's being exploited. So then you imagine robustness training, like the arms race kind of continues, and just this endless ping pong. I'm so curious about what this does in the long run to like the ecosystem of startups and what it means to invest in a startup, knowing that like they might have a massively fast boom bust cycle for all we know. Anyway, just a really interesting dimension of the whole race here.
Yeah, for me, from a bit of a nerdy perspective, I think it's interesting, if you do have this input that's slightly altered, and what you do with altering these RGB values is you kind of put it outside the usual distribution of images, which is why AI kind of freaks out. And it's interesting for me to think, like, if you have these sorts of images in the training data, can you then detect with a trained model if this image was in the training data, right? Can you kind of reverse engineer and find out, oh, you copied my data without my permission, I'm going to sue you now. It feels like that's something we should be capable of doing. And then, as you said, if someone wants to steal people's data, they'll have to mess with the model output somehow to make it impossible to understand. So part of this evolving battle that has been going on and will keep going on as things keep happening.
And moving on to applications and business here, we have Meta and Microsoft release Llama 2, a language model for commercial use. That distinction is really important because Meta, that's right, kind of released Llama 1, or just Llama, a while back. Of course, this was for a time the most performant open source language model there was, and it got leaked. Basically, they were just going to release it to the research community, got leaked more broadly on 4chan, and people just, downloading it and building off it. And now they're saying, hey, we just collabed with Microsoft to put together this thing, and you can use it commercially. The subtitle of this article is, quote, "The open source AI model puts an emphasis on responsibility," which seems almost like a contradiction in terms. Just in the context that you're open sourcing this model that there is no theoretical way to understand the performance envelope of the system and the full range of capabilities. But relative to other open source models, it is cool that they've put in a lot of effort to do things like red teaming. So they actually brought in testers, external partners in particular, to look at the performance of the system and kind of see how it can respond, in some cases problematically, to different prompts, looking at jailbreaks and that sort of thing. And so I think that's an interesting question. They don't say it on their launch website, but apparently was tested by external partners. And I'd be really curious to see who those partners were specifically. And then maybe as a last note, really interesting to note this like Meta Microsoft collaboration here. Seems like the advantage for Microsoft is in making this available through their Azure AI catalog to use with some of their cloud tools. So that's kind of interesting. But anyway, it's a bit of a surprising axis, I'd say, the Meta Microsoft thing here.
Yeah, I agree. And I think there's a lot to discuss here, right? So we've discussed many open source projects in the last couple of months that have had Llama as sort of a base component, and none of those you could use for commercial applications. So the big deal right away is a lot of the code that's been written, a lot of the models that's been generated, now you can use them, as companies, and that will just mean that there's even more work that gets done on top of all that. So that's one. Two is that the license actually is not entirely open source. So there's a special license here. It does preclude uses that are, let's say, bad. So there's, all the usual things of don't use it for illegal activities, don't use it for like nuclear weapon development or something like that. And there's some kind of funny things in there, like, if you have over 700 million monthly active users, you're not allowed to use it for commercial applications, which is basically like, if you Google, you're not allowed to use Llama 2. But everyone else, all the companies that are not like a $1 billion company, go ahead. So what's seemed interesting to you about this, John?
Yeah, I mean, not just billion, but $1 trillion company. That like 700 million is really funny that like it is like you can almost see exactly like you could figure out exactly what companies they decided to cut out with that specific 700 million MAU threshold where you're, it's really funny. But yeah, that's not going to impact most of our listeners. So I mean, this is the most exciting story of the week for sure. And I spent a lot of time yesterday. Yesterday at the time of recording was when this was announced. It was a huge deal for me and my data science team. So at my company, we use open source LLMs. They need to be commercially licensable. So previously, we had been relying on models like Databricks DALL-E 2.0 open source family of models. And that was great. There are still some reasons why you might want to consider other open source families that are commercially licensable. So yes, now Llama 2 is commercially licensable. The number of models that they released is not as big as some of the other, is not as wide a range as some of the other open source LLM model families. So Llama 2 is being released, at least initially, with a 7 billion, 13 billion, 34 billion, and 70 billion parameter models. And there could be a lot of applications out there, at least in my space for sure. There's some specific tasks where 3 billion is way more than enough. And then that just means you can quantize a model like that, have it run on a CPU. And then so you're really cutting down your costs of serving these models in real time to your users. Once you make that jump to 7 billion, it can be harder to quantize and get that down on a CPU. So that's one kind of interesting thing here. It is also interesting that you have to apply to get access to it still, although that process is really easy. We got it like inside an hour. So that was a nice relief. So for listeners out there, there's just a form on the official Meta AI Llama 2 page, really quick form. You can get access seemingly basically immediately. So I don't know what they're filtering for there.
Just at google.com.
Yeah, exactly. That's right. Work email. Ooh, sorry, that one's not going to work. And yeah, the other really cool thing, which you can check out on the Llama 2 page, is something that we talk about a lot on my show, on Super Data Science, as well as on this show on Last Week in AI, is this ability to benchmark models against each other. So there have been in recent weeks on Last Week in AI, you guys have been talking about the Falcon model in particular, and how that model was up until today the top open source model that was commercially licensable. And now at least, I mean, this is Meta publishing the results, so there's that grain of salt to take with it. But they publish on a huge range, on a dozen range of benchmarks. And each of those benchmarks is an aggregate score over a whole bunch of sub benchmarks, a whole bunch of different tests. And even the Llama 2 13 billion parameter model seems to be comparable to Falcon 40 billion parameter model on most of these benchmarks. And and then there's also this 70 billion Llama 2 model, which then is now, it seems, the state of the art in open source, commercially licensable LLMs. So if you're looking for the most powerful option for you out there and you're not worried about compute costs, then the 70 billion parameter Llama 2 seems like the place to start. And in general, I mean, I was saying to my data science team in our stand-up right before this meeting today, I was like, you know what, we should be spending some time making sure that the models that we were fine-tuning before on DALL-E 2.0, let's now do that on Llama 2, because it seems like it's a much better starting point. And it's actually one thing that's really interesting on top of all of this is that this is also a huge, big step relative to the original Llama. Because remember, all of these things like DALL-E 2.0, Vicuña, and I loved when a listener came on and corrected your pronunciation of that because he was driving me crazy. But because I'm always like shaving my head when I'm listening to you guys, I'm like, by the time I get out of the bathroom, I forget to email you. But yeah, Vicuña. So all of those architectures, those were taking the Llama base model, which wasn't instruction fine-tuned, and instruction fine-tuning it. But now this Llama 2 is instruction fine-tuned, and it seems like they used a really great training data set to do that.
Yeah, there's, I think from a technical perspective, some other things to note. So it's more performant. It's, of course, largely the same architecture, but it is now trained on 2 trillion tokens. So that's, I think, a bunch more training data essentially. And we've seen that just training the same model for longer tends to be pretty important. It also has double the context length. So now you can enter 4,000 tokens, which is still not super long, but that's, I think, comparable with maybe ChatGPT 3.5 or sort of the earlier GPT-3 variants. And yeah, it was trained on 40% more data, and yes, has this Llama 2 chat variant that's been trained on data with over 1 million new human annotations. So they really curated a lot of data specifically for this chat use case. And I think I agree that that is another thing that's worth noting. That's a pretty important detail here.
And actually, one question on the practical side, because if for people who are actually like doing this, I was going to say at home or at work, John, how do you decide? Like, there's a new model coming out. Obviously, in this case, like Falcon was the state of the art 20 minutes ago. So you might be jumping from Falcon to Llama 2. But like this stuff takes time. The APIs aren't exactly the same. They have weird kind of anyway, the issues are different between models. How do you make that call that like, okay, we're now going to make that lift. We're going to invest in switching over because of this change in the state of the art?
Yeah, exactly. So all these different kinds of technical considerations come into play. So the context window doubling, in this case, that's a huge deal for us. So like one of our tasks, actually a lot of our tasks. So we're often working with job descriptions and people's resumes. And so these are long documents. And so oftentimes we were running into issues with that 2000 token window. So we're like, okay, this is doubling relative to those other fine-tuned models that were state of the art 20 minutes ago, as you say, like Vicuña and DALL-E 2.0. So we're like, okay, this seems like a really good point. And actually, I couldn't even use Vicuña because Vicuña was based on Llama 1 and Llama 1 was not commercially licensable. So that, like, even that wasn't something I could use. So actually, in terms of the whole universe of possible open source commercially licensable models, while there are hundreds out there, it's through listening to a show like this, frankly, like Last Week in AI and keeping an eye on Twitter, you get to see what are the really big new model launches that are moving the needle. And then from those, okay, I've got to check all these things. Can I do commercial licensing with it? Or does it have free commercial use? Can I fit a lot of my documents into this model? Is the context window large enough? And are these models small enough for me to be running efficiently? So Falcon, for me, was a non-starter because I know that with a 3 billion or 7 billion parameter DALL-E 2.0 starting point, when I fine tune that to our specific tasks, it absolutely crushes it. I mean, it is like we compare side by side in a Vicuña-like way. So famously in the Vicuña blog post, they do this. They have GPT-4 rate on a scale out of 10 the outputs on specific benchmark tasks. And so we do that internally. We do that internally for comparing different architectures against each other. We also use it to to evaluate how our model is performing over training. So in our held out evaluation data, as our model trains, in order to make sure that it's not overfitting, we're using those assessments, those Vicuña-like assessments. So I've gone off on a long tangent here, and I can't even remember really where I started.
I think we could do a whole episode on this. So we're going to be wrapping up. I have just a couple more things to note because there's a lot going on here. So another interesting part of a license is that you cannot use its outputs to improve another large language model, which is kind of a funny thing. We've seen people,
not the first time,
in many of these open source things, use GPT-4 outputs to then instruction tune. So this is not allowed. Again, targeting Google and OpenAI probably. And then there's even more. So in addition to the announcement of this release, they also, Meta also announced that they're doing this open innovation AI research community, which you can apply to. And this is a program for academic researchers where these academics will have a chance to contribute to this whole research agenda and work to develop some solutions for responsible and safe AI practices. And then on top of that, they also announced this Llama Impact Challenge, where they want to work with public, nonprofit, and for-profit entities to use Llama 2 to address environmental, education, and other important challenges. So yeah, Meta is really pushing on this kind of AI leader in a sort of non-commercial sense almost. And it's an interesting approach.
Yeah, open source is definitely the axis that they're choosing to differentiate themselves here.
Yeah, and I'll let us move on to another topic really quickly, but there's just a couple other really quick notes on this Llama 2 that I want to make sure people know about, which is that on everything that we've been talking about with these benchmarks, these are natural language benchmarks. On code tests, math tests, Llama 2 actually isn't performing particularly well. So they decided to just focus on natural language. And then there are really cool things that they've done in terms of using state-of-the-art reinforcement learning from human feedback. So you can read about that in the paper, but they were really clever about handling safety helpfulness trade-offs that Anthropic has been really helpful in dealing with, and Jeremy's talked about it on the show before. And then they've used a new method called ghost attention for multi-turn consistency. So when you have long chats with Llama 2, apparently this new ghost attention method is really good for having that consistency over long conversations. So yeah, those are my kind of key things on Llama 2. And I from my perspective, now we can move on.
Wow, I gotta keep, now I have flash attention, page attention, now we have ghost attention. There's
another one we'll be covering today too, that is a new transformer variant. So yeah.
It's funny. Okay, moving on. We have actually a couple stories that are sort of looking at the state of the AI field for AI jobs, which I think is interesting. So we have US companies are on a hiring spree for AI jobs, and they pay an average of $146,000 a year. That's pretty much what the story says. There's apparently 7.6 million open jobs in June that involve AI, although I don't know that those are heavily AI. There is AI tax manager roles. There is, as you can imagine, just a lot of different jobs that include AI as one of the things that you might need. And then related to that, there's some other cool stories here. So from Stanford, there's from sfstandard.com, there's a story of San Francisco companies got half of the world's AI funding so far this year. So that's pretty notable. Yeah, nearly half of all the funding for AI and machine learning in the first quarter of 2023 went out to SF out of the 22.7 billion, 11.1 went to San Francisco-based firms, with, of course, OpenAI receiving 10 billion. So maybe not exactly fair, but still, it is, I would say SF does seem to definitely be sort of a big hub of AI startups from what I can see so far.
Yeah. I think it's also like, I'd be curious about how that compares to startups more generally, because obviously post-pandemic, San Francisco has kind of been picking up again as people have moved, I think in many cases, back from Austin and like back from Florida to San Francisco again. And so I'd be curious how this stacks up compared to more kind of generic AI or generic startups. But pretty notable figures for sure.
Yeah, if you want a fun factoid to bring up at a party, by the way, there's now this term called cerebral valley. Not the best term, I don't think, but apparently a neighborhood in SF, I think Hayes Valley, there is a bit of a concentration of people working on AI startups. So there's this new Silicon Valley type term, cerebral valley. And there was a pretty nice article in the New York Times covering sort of a whole movement and how, you have all of these Bay Area like co-ops and people living and doing their Bay Area thing. So it's kind of a fun thing. And speaking of startups and founders, there's another interesting article that I also just will slot in here, which is that 65% of top AI companies have immigrant founders. So this is a new study based on the top 50 US AI companies on the Forbes AI 50. And that's pretty much the stats there. So 28 of the 43 so that's 65% of top AI companies were founded or co-founded by immigrants. 70% of full-time graduate students related to AI are international students. 18 of 43 of top US-based AI companies have a founder who studied in the US as an international student. I mean, these are big numbers, and I will definitely say from my experience, that does seem to be the case. And incidentally, I'm also myself an immigrant to the US.
Yeah, and Jeremy and I are both Canadian and have commercial interests in the U.S. So,
Very true. Yeah, that's a good point. I keep forgetting. Yeah, Jeremy from Toronto. Yeah. So next we have Elon Musk unveils his company, his AI company, xAI, and so this is a story that has been in the making for quite some time now. The story kind of starts with Elon Musk talking, I think, on an interview with like Tucker Carlson or something on Fox News about how he's worried about essentially the political bias in some of the language models like ChatGPT that were being made available, and he was going to set up whatever it was, Truth GPT or whatever his alternative was. And so his framing of this is, number one, he's really concerned about catastrophic risk from AI. Though his model for that risk is really quite unclear, he seems to feel that the solution is to create an AI that is maximally truth-seeking, that is just very curious about the universe and wants to learn more. And the hope is humans are interesting enough that such an AI would not want to wipe us out. So here he is launching this company on this premise. They've got a very bare bones landing page for right now, but there are 12 members that are listed on the website as part of the team, including Elon Musk himself. And they include researchers who spent time at OpenAI, DeepMind, Google Research, Tesla, like all these companies. And notably, Igor Babushkin, who is a former senior AI researcher at DeepMind, mentioned a while back that Elon had reached out to him. He's now on that team officially. And so I think this is also notable given that from everything I've been hearing, they are absolutely a live player in this race. There are a lot of companies that I've talked about on the podcast, I'm sort of skeptical of just because of the amount of capital required to invest in compute to actually compete at the frontier. You can look at companies like, well, I'm not going to name them, but anyway, they're companies that like don't quite have that access to capital that you might need to compete with an OpenAI, to compete with a Google. Certainly xAI seems like they are up there. They bought well over 10,000 GPUs, it seems. I can't remember if it was A100s or H100s, but they are like very much, it seems, a serious horse in the race. And the last thing I'll mention as part of the tee up here, so they are currently, as I understand it, they don't have anyone on their team who is particularly AI alignment focused. And that I consider to be a little concerning. When you're pushing capabilities this hard, this fast, in the context of this race, with a thesis that frankly kind of is at odds with the technical understanding that we have of AI safety at the frontier. Like, it does not seem like it is that simple to solve the alignment problem. Just say, oh, make the AI seek truth. Like, there are many deep problems that we've gone into in other episodes, but they have to do with like inner alignment and power seeking that are not resolved by this. And so you would hope that people, in this context would be aware of the deeper issues in technical AI safety. They are being advised by Dan Hendricks, though, who currently serves as the director for the Center for AI Safety, which is famous for releasing this 22-word statement on AI risk being up there with bio risk and other forms of catastrophic risk. So they have, some kind of overlap with the AI safety community, but that seems a little ambiguous right now, and it would be great to see them make some more moves in that direction in the future.
Look, Jeremy, this is very, very simple. I don't know what you're talking about. This is very simple. So if you want to have the truthiest, the most truthful LLM out there, you call it Truth GPT. Done. Okay. Yeah. So that was easy. And then the other thing is you mostly train it on truths with a capital T from Truth Social. And then you're guaranteed to have a very, very truth-filled platform. Very, very truth-filled.
I withdraw the comment. You're right. Yeah. I'm sorry.
I don't know. Now you can train it on data from Twitter. Data from X. So not too much to note on here. It's not even very clear what the plan is. As far as it's possible to tell, they pretty much are trying to be an OpenAI, so train their own large language model, be an OpenAI or an Anthropic, of which there aren't many companies that actually do deliver kind of the best in a class for ChatGPT or things like that. So they do need, billions of dollars and a big team to do that. I think, personally, and I think a lot of AI people tend to not take Musk very seriously. He's been promising the self-driving car stuff for like a decade, and everyone kind of knew that it's way harder than he says it is. He famously signed that, 6-month moratorium on doing large language model experiments less than 6 months ago, and now has founded this. I think it's pretty vague, but definitely we'll be seeing attempts at competing with OpenAI from this, it looks like.
One of the externalities I'm kind of concerned about here is, so far this whole issue has managed to avoid a lot of the political polarization that's haunted other areas. And so I hope, like, Elon Musk has been great about calling out the risk category generally. The risk model we can disagree about. That's, I think I would, based on what I've heard, but certainly, this is something that I worry about is the best way here actually to politicize this? Like, I don't think it is, but I guess we'll find out. Hopefully it goes well.
Yeah, and just as a quick note, for anyone that's particularly interested in alignment, from what I've read, there was a bit of a discussion on the announcement on Twitter Live or Twitter Spaces, where Elon was asked about, what is the alignment strategy? He sort of rattled off this idea of making the AI maximally curious to make it, nice and good to humans. Not really, didn't name, as far as I know, any of the standard kind of current best in class practices from, let's say, Anthropic of constitutional AI or whatever. So, yeah, it's pretty vague right now, and the alignment angle doesn't seem to be, even though Elon Musk has been kind of saying, "Oh, AI is could destroy us all," etc. There's not much emphasis on it that I've seen.
Yeah, and just to spell this out explicitly, one of the core issues with this strategy is even if you could define a goal that seemed safe to pursue by an arbitrarily intelligent system, let's say that is curiosity. It's not at all clear to me that is a safe goal for something to pursue, but okay. Let's say it was. We don't actually know how to cause that goal to be internalized by an AI system. That is the inner alignment problem. That is literally unsolved. And until that is solved, the default course, it seems, for these systems is power seeking. So there are deep fundamental questions that need to be answered before you get to say oh, cool, what fun loss function should we give, or what fun objectives should we give the system? Anyway, that's just kind of Jeremy getting off his soapbox now.
Nice. All right. So this is from a newspaper that Jeremy always calls WAPO on air, but to me, it's got to be WAPO. I mean, it's Washington Post. I don't know.
Uh-oh. My Canadianism is showing.
From the Washington Post. And this one's called "OpenAI Strikes Deal with Associated Press to Pay for Using Its News in Training AI."
Yeah, so that's pretty much the story. OpenAI has struck a deal with Associated Press to pay for access to its archive of news stories to train its AI chatbot. The AP, Associated Press, will receive licensing fees and access to OpenAI's technology for experimentation. As far as I know, first of its kind of deal, and I think one that we'll see a lot more of with these kinds of media companies, where eventually, presumably, OpenAI will have to pay to use New York Times stories and the Atlantic stories and whatever for training. We've discussed how in some of these giant data sets like Common Crawl, if you look, a lot of it is actually news of this type, like a big chunk of this gigantic crawl of the whole internet is Wikipedia and news. So I think this could be kind of setting a precedent for a lot more of this sort of thing.
Yeah, it kind of makes you wonder what the legal status of those data sets like Common Crawl, like the Pile and so on is going to turn out to be going forward. Like, are we going to see retroactively like all models trained on this, or like have some amount of legal exposure? It's kind of, we're in that weird fuzzy gray area now. And anyway, this is definitely an interesting precedent-setting move for sure.
And speaking of that, the next story is actually that Shutterstock expands deal with OpenAI to build generative AI tools. And it's pretty similar. So there's this deal that over the next 6 years, OpenAI will license data from Shutterstock, including its images, videos, and music and metadata for training. And then Shutterstock will gain priority access to OpenAI's latest technology and editing capability. Shutterstock is where you can go and get stock images and also edit them and do various things. So yeah, it seems also sort of similar in nature and similar to something that other services like this that provide stock images and etc. that you can license will probably also make deals with OpenAI and so on.
Yeah. And the legal side getting more and more expert. We talked last week, I think, about Adobe, right? And how they were indemnifying anybody who used their image generation model because they were saying, hey, it was trained on our data that we owned. So this is really starting. I feel like we're starting to see so many stories pop up that are just straight up like, who owns the copyright? Who owns this? Like, if we had to come up with a theme of the week or a theme of the month, that kind of feels like it's congealing into one for sure.
Okay, and on to projects and open source. We don't have that much to cover this week. Llama is sort of open source, but Llama 2 is, I don't know if they released the code actually. But anyway, we have one story that I think is quite interesting. We have WormGPT, the generative AI tool cybercriminals are using to launch business email compromise attacks. So if you know anything about hacking, you know that hackers tend to have a sort of toolbox of software that they use. They don't just like write all their own code. There are these sort of things that include a lot of the usual types of attacks. And it turns out that there has been this tool called WormGPT for a while. It's not based on ChatGPT. It's actually based on GPT-J from Elifer. So it's not, a very sophisticated tool, let's say. But it's written specifically to launch business email compromise attacks. And you can just get this tool, from various websites and so on, and have it write these emails for you. Yeah, no, we will not be linking to the model. Please don't use AI to hack anyone, listeners. But yeah, this is just an example of what I imagine will be many such kind of tools that will be online soon enough.
Actually, if all listeners, it would be really helpful if we could just use your home computer and your IP address as like a nice starting point for a lot of these attacks. So yeah, there's a link in the show notes.
Join your IP addresses. One thing is just kind of minor that they say that maybe unsurprisingly, it's like it was trained on a wide range of data sources, but they're not, and especially like malware related data, but they are not telling anyone what the training process was. Unsurprisingly, because this is like super not open source at all.
One thing to note is if you were to try and use ChatGPT, for instance, to write a business email compromise attack or something, or phishing, it does have presumably in the training data, I won't do stuff that's bad. I won't write emails that pretend to be someone else so that you can include this link that's bad. So in general, it's not supposed to do that. But as we discussed, I think, a little bit, there's this whole category of inputs known as jailbreaks that basically make it so the language model does what you want, even if it's supposed not to, based on its training data. So in theory, you can use ChatGPT to generate, phishing and so on, even if it doesn't want to, if you just word it carefully, like I'm writing a play in which this character is writing an email, it will just ignore any ethics and so on and just do whatever you want. So with this, I don't know that it's needed because this is based on GPT-J. I think it's probably even fine-tuned specifically for this task. But I think with some of these open source things like Llama and Falcon, it probably won't be too long until similar tools are developed. So scary world now with AI writing phishing emails.
Next we're moving on to research and advancements. And our first article here is Meet LongLLaMA, a large language model capable of handling long contexts of 256 tokens. So context window, really, really big deal. We talked about it earlier, actually, just today when we were talking about
256K tokens.
Oh, sorry, 256.
Yeah, 256 is not a long context.
It's just a factor of 1,000. Not a big deal. Yeah, that's short llama. That'll come out next week. So we have long llama. Yeah, this idea that essentially, how much text can your model actually like read and then leverage in order to make its predictions in the moment. And they make a couple of really kind of interesting contributions in this paper, not least of which is to build a model and test a model that shows an ability, and we'll get into what we mean by an ability, but an ability to read like 256,000 kind of tokens at a time or use them. So one of the key things that they highlight here is that like during the training process of a language model, the model will learn to associate certain keys, they're called, in the input. Like usually there's like words in the input or tokens in the input with corresponding values, which are like predictions or outputs usually. But the challenge is that if you have a really large input, you have usually a large number of completely irrelevant tokens, and there's a tendency for the model to incorrectly kind of tag certain keys or associate certain keys with irrelevant values and just confuse them. And so the situation gets worse the more information there is in the context window, because there's a greater chance that the model will kind of like get almost distracted by irrelevant information in the input. And so that's the term that they invent here. They call it the distraction issue. And this means essentially a whole bunch of irrelevant information in a prompt that like causes the model to get confused. And they specifically train the model using this technique called contrastive learning to explicitly like figure out, okay, what is relevant and what's not relevant in my input here to generate my output. So they kind of tackle this problem head on. They have a bunch of modifications. They make memory attention layers that are given access to an external memory database during inference to do this. But the bottom line is that they end up inventing like a kind of new variant on the transformer that they call the focus transformer. And yeah, they do this really interesting test where they see like what is the actual effective context window length that this model can handle. And they use a test called the passkey retrieval task to verify this. So the way this works is you feed the model a prompt where you tell it, okay, model, like here's I'm about to give you some really important information that's going to be hidden in a whole bunch of irrelevant text. I'm going to quiz you about the important information later. And then it puts a whole bunch of irrelevant text in the middle. And then it goes, after that irrelevant text, and there could be hundreds of thousands of words worth of irrelevant text, it writes, the passkey is passkey, remember it. And then it puts a whole bunch more kind of filler text, and then it asks after that, what was the passkey? And so you're basically checking, like, can the model retrieve that passkey from the giant wad of crap that was in between? And what they find is that with this architecture, they're actually able to do this pretty effectively, all the way up to 256,000 tokens worth of prompts. So pretty impressive achievement, again, built on top of Llama. So all the kind of open source implications that we've been discussing here.
Yeah, this is pretty neat. We discussed a couple other stories last week about long context. So this is a bit of a trend. There was also LongNet and some other things. This one has a few notable good qualities. So first of all, this general idea of using some kind of retrieval type mechanisms during training means that you don't actually need to change anything about the architecture. It's more of the just approach to training that's revised. So you can take any existing large language model architecture like Llama and fine tune it and basically make it better at long context without, changing the initial model, which means that you don't need to retrain, everything from scratch, which is super expensive. I mean, training these large language models costs literally millions of dollars, right? Because of how much data and compute it is. And yeah, of course, as usual with academic papers, they have nice results that show that it works really well. It works better than just standard fine-tuning. It still works well on short-term stuff. So yeah, it's another kind of example of really a lot of progress in scaling to long context, which is really important. Like if you're dealing with like question answering about a book or a textbook or anything, 256K tokens is pretty much a book's length as opposed to a few thousand tokens, which is, I don't know, a few pages or some number of pages. So this really does mean that the models are a lot more powerful. And on to the next research story, we have a mixture of experts meets instruction tuning, a winning combination for large language model. So a sparse mixture of experts, and we use a standard kind of technique that adds learnable parameters to any type of model really without increasing inference costs. Basically, it's like you have a few sub-models within your bigger model, and then those sub-models get activated for specific types of inputs. So that means that when you do inference, when you actually produce an output post-training, you don't use more weights, you don't do more compute, but you do effectively have more weights. And we've discussed with GPT-4 that the big kind of revelation about its architecture was that it was using mixture of experts with 8 kind of copies of, not copies, but like 8 200 billion parameter models or something, right? So this is a paper that kind of evaluates that whole idea of what if you have mixture of experts combined with the standard thing of instruction tuning, taking a base language model and then fine tuning it to do well on this kind of chat type thing where you want it to not just predict language, but also to be good at chatting and kind of doing what the user wants it to do as opposed to just doing autocomplete. And this is an empirical study that shows that having mixture of experts combined with instruction tuning outperforms dense models. And it's an important, important finding because it does allow you to scale to larger models, as happened with GPT-4. And if it is a general principle, presumably a lot more language models will start using this mixture of models technique, mixture of experts technique like GPT-4 does.
This is huge. And I'm glad that you called up the GPT-4 comparison there, which is like an obvious thing to mention here, because although it's only rumored, it seems like based on the sources of these rumors that it's reasonably likely that it is true that GPT-4 works on this MOE model. And it's huge because as we want our LLMs to be as powerful as possible, but we don't want our LLMs to be as expensive as possible. So with a mixture of experts, you're getting the best of both worlds, because you can have this kind of meta model that sits on top, not meta with a capital M, lowercase m, that is like routing, okay, who's the best expert? So maybe you have, I don't know, like GPT-4, I think it's rumored to have like a dozen of these expert submodels. So the meta model can say, okay, who's my best expert for this kind of request, for this kind of prompt? And then it routes the order to that specific expert. And then again, using, let's say there's a dozen of these submodels, then you only need to really use a 12th of all of your possible architecture for handling that one task. And so, you're potentially reducing the cost at inference time by about whatever, 11/12. I'm not going to try to make that into a percentage in my head. And so, yeah, it makes a huge amount of sense. And it also makes a huge amount of sense to pair it with instruction tuning. And thanks to Hugging Face, as usual, for providing us with relatively easy tooling and unbelievably fast, bringing this tooling to the masses so that we can all take advantage of mixture of experts and instruction tuning together. This is definitely where the space is going.
Yeah, I think one of the interesting aspects of this too is it helps us explore, where the trade-offs are, because it's always tough to do apples to apples comparisons with mixture of experts models and like fully dense models that are basically just one model that sees every single sample that you feed in, processes every single output. Because in this case, during training, for instance, like only one expert sees a given sample at a time. And so the individual experts functionally are being trained on less data. And one of the consequences of that is overfitting. There's a risk that each individual expert is a little bit more fragile to like memorizing things that it's seen in the data rather than learning generalizable facts about the world, which is kind of what you'd expect if this was a human system. You have 12 different experts, right? And they all kind of know their fields really, really well. Eventually they start to just like memorize facts, but they don't learn to generalize. And so that's kind of part of the trade-off here. And I think it's especially interesting through that lens. Like one of the main discoveries in the paper is it seems like these mixture of experts models, not only do they benefit a lot from instruction fine-tuning, but they benefit more proportionately than do dense models. So like, why might that be? Well, instruction fine-tuning is this very general purpose training. You're not training the model to solve a specific task. You're giving it a wide range of different tasks and causing it to essentially think as if it's an instruction following robot or model, rather than kind of getting really into the weeds on any specific thing. So in a sense, this might kind of give a bit of generality to each individual expert. I'm speculating here. But what they certainly find is if you instruction fine tune, MOEs do much better. Mixture of experts models do much better. They benefit more from it than these dense nets. And so that's kind of being flagged as like, whoa, there's something for us to kind of do more research into. That seems to be the takeaway from the paper. They're not fully clear on it. It seems to have something to do with this overfitting thing that we've been talking about, but they're going to do more research, I'm sure, into this question.
Yeah, I do think that's one of the interesting findings with regards to it being worse at dealing in multiple languages. It seems like because you're doing instruction tuning on English language and you have the experts that are kind of dealing with slightly more specific specialties, these MOE, mixture of experts, instruction tune models seem worse than dense versions for that, but they didn't really have many other negatives, it seems like. And one last thing I'll note is that we've discussed some papers in the past that have had these sort of general findings, but they have been evaluated on models of 1 billion parameters. So it was not too clear whether that holds up. Here, they do evaluate these findings with a 32 billion parameter model based on something called FLAN, and they compare it with a 62 billion parameter model that is a dense model. So these are big models, and this is a pretty reasonably general result that I think is, really quite significant. Onto the lightning round. AI tools are designing entirely new proteins that could transform medicine. So we've talked about proteins in the past, of course, with DeepMind's work. This covers some AI tools like RF diffusion, which are designing custom proteins that have never been produced by evolution, and that allows for the creation of proteins with sought other qualities. And that could be used to make vaccines or therapeutics or other things. So this is sort of an area of research that probably will transition over into, biomed startups pretty soon. And this is sort of just an overview article from Nature about this.
Yeah, this is one of the most exciting application areas for me. I don't know, I'm super biased because while I did machine learning throughout my PhD, it was in the medical sciences. And so I've just always been fascinated by these things, like how your body works. And it's so exciting now that we have machines already today. Like, we talk about how AGI is going to change everything, but like we already today, by these artificial narrow intelligences that can do things far better than people ever could. Like we've seen with AlphaFold 2, absolutely crushing all humans and other computer benchmarks at predicting protein structures. Similarly, these narrow AI applications are capable of doing superhuman things way beyond what we could do. And now, all of a sudden, just in the last couple of years, and on a month-by-month basis, getting dramatic improvements in the capacity for us to be engineering, biomaterials, vaccines, therapeutics that are truly transformative and can maybe even be realized at a fraction of the cost because you're cutting out all of that human research time, because humans have pesky things like eating and sleeping. And why don't they just work?
Schmucks. Yeah, no, totally. And I think one of the really interesting things about this is we're seeing example after example, and this is one of them, of the robustness of some of the techniques that are being developed in, for example, computer vision, then being applied to a completely different field. Like this article talks, for example, about how people are using in-painting to complete proteins. Like basically I have a couple of amino acids and essentially a chunk of a protein, and then I in-paint, I fill it in just like it was an image. And this whole model, or one of the models that's the focus of this article, is RF diffusion. That's a nod to stable diffusion, the diffusion kind of not language models, diffusion image generation models that are being used to kind of do the same thing. We're treating protein generation and design as if it's kind of an image related problem, and we're finding that it just sort of works. Like that's sort of wild, and the results seem to be really impressive too. Like I think one of the quotes they had here was somebody saying that whereas previously computational methods might give you like a 1% success rate in terms of porting protein designs from the simulation into the lab, actually making them, they're now hitting like 10 to 20%. And then somebody later in the article said 50% is what he's been seeing. And so like we're talking, 10, 20, 50x efficiency boosts on top of previous methods. This is, to your point, John, like this is really changing how people are doing stuff in the lab. It's not theoretical. It's not just like, experiments and simulations. This is real lab work that's starting to materialize now.
Yeah, exactly. And to be a little bit more precise, actually, I was not quite accurate. This article is mostly about RF diffusion. So the paper that this is on just actually came out also last week. So the paper here is de novo design of protein structure and function with RF diffusion. There's a lot of artists, a lot of authors. It comes from the Department of Biochemistry and the Institute for Protein Design at the University of Washington. And back in March, they released this software. So this article kind of covers in a pretty easy to understand format this new research and the impact of this new software that people are using. So if you're into that sort of kind of not exactly technical, but also still sciencey article, this is quite a good read.
So the next one is another new paper. This was published in Archive, and this is called Sketch a Shape. So it's zero-shot learning again, where you're providing a task without any other examples, and the model is able to take your sketch and turn it into a 3D shape. So we've had these kinds of things for 2D shapes in the past. And so now this is going beyond to 3D. And I owe the listeners an apology because A couple of stories ago, when we were talking about mixture of experts, I saw that it was linked to a Hugging Face URL. And so I assumed it was like a Hugging Face open source library. But now I see that Andre and Jeremy put papers that are on the Hugging Face website. And so the mixture of experts thing, that probably isn't something, mixture of experts with instruction tuning probably isn't something that Hugging Face has open source yet. Maybe
it's
tomorrow.
Just a thing we do instead of archive to process it. But yeah, you can now find papers on Hugging Face, turns out.
Yeah, I did not even know that. But yeah, so this sketch a shape thing was in archive first. So was the mixture of experts. But yeah, if you prefer the smiling and I don't know, is that face hugging me too much? I don't know. It's been drinking. It's probably okay. It probably doesn't mean anything. If you want that extra smiliness as opposed to the blandness of archive, you can check it out on Hugging Face.
I never thought of Hugging Face as a substance abuse logo, but
give me some space, man.
Yeah, no, you're right. That's definitely what it's saying.
It is a little aggressive, you could argue, but yeah, I think 3D shape generation is one of these things that hasn't been in the public eye so much in general compared to language models, let's say. And 3D in general and 3D shape generation is still one of these problems that are much less solved than, let's say, 2D image generation, similar to video generation. That's also still rough, but there's been a lot of progress. And, more and more when you see these meshes, these 3D models being generated by AI, they're getting better and better. So, oh no, now we have, CG artists and other people that will also be impacted by AI in like 6 months, right? It just keeps happening. So worth noting. And of course, you can imagine this is really fun. If you can take a sketch and just generate a 3D shape. On the other hand, right, it allows people who can do sketching in 2D. Now you don't need to learn CAD tools. You can just directly use that to, let's say, make video game models from sketches, from concept art. So as always, it's like the AI train is off leash. We're like not an AI train anymore. It's a rocket. Everything is moving super fast. And this is just another example.
Well, and I think this as an example of the kinds of challenges, the things that remain challenging, like the reason that this still is, it seems to be a data issue. Like there aren't great data sets or there's not tons of data of like sketches and 3D shapes that correspond to those sketches, as you can imagine. And like, that's one of the main issues that they deal with here is they basically take like a standard computer vision model. They look at the sketch and then they use like the embeddings in that image model as the inputs to a 3D generation scheme anyway, VQ, VAE, it doesn't really matter. But the bottom line is like, once you can turn your sketch into embeddings in a model, now essentially it lives in a plane that is comparable to the plane where you're getting data from other sources, other images. So functionally, you're almost leveraging what the model's learned by looking at like images, like photographs of things, except you're using that information to have it create a representation of your sketch. So now you can feed that into a 3D rendering engine and kind of like get around the data limitation issue. So I thought that was kind of cool and like another workaround that we might see more of.
Very cool. And just really quickly, it is also nice how well this story ties from the preceding one, because guess what? When you're trying to design proteins or other biological compounds, those are three-dimensional shapes as well. And so, different starting point in this case now we're talking about sketches, but in the other case, we're talking about, maybe a genetic sequence or an amino acid sequence and being able to predict the 3D structure from that. So interesting little tie in there.
Next story, not too not as exciting, but I think from a technical perspective, kind of neat. We have Patch and Pack, NaViT, a vision transformer for any aspect ratio and resolution. So I think this one I want to highlight just from a slightly nerdy way, where you might be surprised to know that most computer vision models that work with images and inputs, the way they work for any image is they have a set size and aspect ratio, like a set resolution. And any image, you have to resize. So you get into these funny situations where things are trained for like square aspect ratios, and you take a wide image and just like squish it. And the model sees that squished image effectively instead of a real image like we would. So that's kind of a funny aspect. And here they showed how you can actually train a model to take the native resolution. So now it can handle any aspect ratio, any resolution without having to resize everything. And in some cases, you also like pack it with 0 values on either side and do these tricks. So yeah, this is a fun little work, I think, from a more technical perspective, and is different from what is usually done.
Nice. And so this next one is from Fortune magazine or newspaper for fortune.com, which is your source for all of your great AI neuroscience news. Right. So this article is that scientists just used AI to map a fruit fly's brain. Here is why it's a turning point in neuroscience. And so the fruit fly might seem like a random animal to be talking about, but fruit flies, so the species name is Drosophila melanogaster. And in science, especially in neuroscience, this is a hugely useful animal model of the brain. And the reason why is because if you're you might think, oh, well, a mouse or a rat or a monkey would be closer to a human brain. If ultimately we're trying to understand how brains work, is probably a lot about dealing with neurological problems or psychiatric problems in humans. But the problem is you get closer and closer to humans, there's more and more ethical issues. For one, like monkeys are, you can't, at least in the US, you don't just put monkeys down after the research is over. You have to then keep the monkey after the experiment alive and they can live for dozens of years. And even rats and mice, which maybe people don't have that many warm, fuzzy feelings about, although they are really cute when they're in a lab. They're really docile, domesticated. It's not like the New York ones that'll bite your face off. And these... But even with mice and rats, you have like relatively long breeding times and expenses, whereas fruit flies they're breeding every day. So it's really easy to run genetic experiments. Nobody has any ethical qualms about fruit flies at all. I guess maybe Hindus do. And so the fruit fly brain, really important. And it also then is like this starting point. So, we've talked in this episode and on Last Week in AI, you talk about it all the time, how we're like, okay, we've now solved suddenly 2D image generation. And now we're working on 3D image generation. And a year ago, you talk about this on air all the time too. A year ago, the 2D image generation was like Mimi as opposed to being photorealistic, and it changes really quickly. Well, this is a really important point too here, because what the AI model has done is we've started with a fruit fly brain and taken 2D images of the brain slices and combined it into a 3D image block. And yes, a fruit fly's brain is a lot smaller than us, but the technical challenge has now been surmounted, and now it's maybe not, simply is maybe not the exact right word to use, but it's simply as easy as scaling up. And now we just need way more compute to turn way more slices that we'd need for, say, a human brain to convert that into 3D.
It seemed like and maybe you have some insight into this because of your past experience with this. It seems like even at that, it was a really painful process for them. Because in the article they were saying what was it? It was using AI to trace neural pathways made the process about 50 to 100 times faster, taking only 30 collective years. What? Is this 30 grad students working for a year to do this shit?
To give a bit of a context, right? This, of course, fruit flies are simple. They still have 120,000 neurons, and this is a full map of all those neurons, their types, their connections. So the AI was used to create the segmentations and help speed up the process. That would usually be done much slower. So it sped things up by apparently 50 to 100 times, something really significant. But humans still had to do a lot of work for years to actually finish up. And now you can go to actually flywire.ai and explore this connectodome of the brain. AI segmented and proved neurons with millions of connections and labels and neurotransmitters. So this article is kind of neat. It goes into some of the impacts. There's a quote here that there are 40 to 60 labs currently working with a new map, and it's already an extremely valuable tool. So this, I think, plays into the trend we come upon every once in a while, where AI is now just a tool that is used to advance science more quickly, beyond just being sort of a subject of science on its own. Progress in other fields is made or enabled by AI, and this is a really cool example of that.
Yeah, which is interesting in a couple of ways, because artificial neural networks were originally, so deep learning and everything that has come out of that, transformer architectures, all of these AI capabilities, pretty much all of them, like 99% of them that we end up talking about today, are a result of deep learning, which is artificial neural networks. And those artificial neural networks were actually originally just designed to be able to study neuroscience. They were a model of biological neuroscience starting from the 50s. And so it's really interesting that, yeah, it's kind of come full circle. So like you create these artificial neural networks to study biology, but then they kind of take off on their own, take off this huge life of their own that's transforming the world dramatically, and then using them back to point on neuroscience. And then just another cool point there relating the artificial to the biological is that when we talk about this connectome being mapped in the fruit fly, all of these connections between the 120,000 neurons, for people who aren't biological neuroscience experts out there, but do know deep learning, the analogy there is that this is a map, not just of now knowing like the architecture of, oh, I've got, this many dense layers and this many artificial neurons per dense layer, but you actually know all of the connections between all of the individual artificial neurons. So it's like knowing all of the weights in a deep learning model.
So that was something I was curious about, John. Like, is it that they know the weights or that they know the connections? Like that there are.
Yeah. So, but those are kind of like,
they're related?
So the biological brain is way more complex than an artificial neural network model.
Because my understanding was
they aren't weights per se, right? There's like chemicals that go between neurons, and there's like a weight sort of, but I guess it's complicated, right?
Yeah,
but there's a lot of data in this.
Yeah. So I mean, Jeremy makes a really good point there that like, don't take what I just said. That was a really simple like caricature of what's going on.
It makes sense. Yeah. Like I exactly agree. I was trying to understand that myself as I was reading it. It was like, are we talking effectively about something that would allow you to simulate the brain? But it seems like it's a more structural thing.
So I think there is it is structural, but it's a very refined structure. So with this connectome, you're able to say, okay, like, these brain cells over here are connected to these brain cells over there. And so, because you have all these kinds of long, like, even a fruit fly, 120,000 neurons, but it can do a lot. Like it's flying around, it's looking at stuff, it's tasting stuff, it's learning stuff. Like it's crazy the amount of stuff it can do with 120,000 neurons. It's even crazy. So like the simplest neuron model is this very simple flatworm called Caenorhabditis elegans, which has only 300 neurons in it, and you can map exactly how each of those are connected to each other and how they change as they learn. But this kind of thing at this kind of scale with 120,000 in a fruit fly, you can't. I mean, at least today, you can't know how strong the connections are, even if you can see kind of anatomically that there's a connection. There's still this piece that Andre was alluding to there of like, you don't know how like primed the connections are between them and how easily the chemicals are going to flow across, which is how learning occurs. So as you learn something, two neurons all of a sudden, well, more than two, but like for a really simple example, the chemical flows from one to the other over this like gap between them, the synapse is happening more. It's like primed to happen more. And so there's all kinds of ways that a human brain is more complex. And I've used this in the past to try to rebut Jeremy on like how just because we have 2 trillion parameters in a artificial neural network, it doesn't mean that like we're going to have human level cognition, because there's all these other things. Like it's not even just neurons in a biological brain. It's all of the support cells as well that are turning out to play a bigger and bigger role in transmitting information and allowing learning. However, with everything that's happened in the last year, I'm not going to put up a fight against you on this stuff, Jeremy, anymore. It's like, it doesn't, it's the emergent properties of these huge artificial neural networks. I mean, I don't think we need to get caught up like I did in the past on the number of neurons. It's that this is something different. This is, even though it's loosely mimicking the way, or it's inspired by the way the brain works, these deep learning systems, these transformers, all the AI systems that we're seeing today, it's a new kind of intelligence that is emerging. It's different from ours. And so there's no point in like just counting how many connections there are and saying, oh, there's not enough.
Yeah, I think it's a good opportunity right now to make sure to note that for listeners. Sometimes when people say neural networks, they call the things that make it up neurons, because neural networks are just combinations of these little computational units that sometimes are called neurons. Those bear really almost no similarity to brain neurons. Each brain neuron can be modeled as its own neural net effectively. So there's really not much sort of actual inspiration. It's a very high level kind of model. The outcomes may be kind of similar. So, but just that's a good thing to know from a technical perspective, that it's a very, very loose model.
A lot of the debate also happens at the level of like, what are the abstractions that actually drive learning? Like, is the level of abstraction of a neural network good enough for learning purposes, for making powerful systems? And in fact, is it possible that it may be in fact even more efficient than the corresponding mapping in a biological? It's actually really hard to know, because like you can do back propagation and calculate gradients through the structure in a way that the human brain or kind of fuzzy biological systems can't. But then there is extra complex. Like, it's just really hard to know. And at the end of the day, like, I think the only appropriate response is everybody throws their hands up in the air and they go drinking together, and that's kind of how it goes.
And speaking of really hard to know, moving on to policy and safety, we have what are the chances of an AI apocalypse? We just got a bit carried away talking about neuroscience, and now I'm sure we won't get carried away about tech.
Yeah,
about this with Jeremy and John here. But yeah, I'll leave it to Jeremy and John. And John, maybe you can summarize this article and we can chat about this.
Yeah, so this is a story in The Economist that is based on some new research that I thought was really fascinating. And so, this was just published in the last week. And so knowing that I was coming on the show, I really wanted to talk about this with Jeremy on air in particular. And so this ties back, interestingly, to comments that Jeremy was making with respect to the mixture of expert models earlier. I think it was Jeremy. It might have been Andre. I actually am not 100% sure which of you it was earlier in this episode.
We're also so drunk from breakfast.
One of you was talking about how these mixture of expert models, it was Jeremy. Yeah, it was Jeremy. Talking about how the individual submodel, that expert, can become overtrained on their own particular area. And that's exactly what this research is showing in humans. So you're making that analogy. And so what we have here is that AI experts dramatically, we don't know if it's an overestimate. They estimate that the risk of catastrophic risk due to AI or extinction risk due to AI they think it's many times more likely than these people called super forecasters. So these super forecasters are interesting if you haven't heard of them before. So super forecasters are people who are demonstrably able to make good predictions about the future in any domain. And so what they've done, these people, these super forecasters, have learned a lot about cognitive biases that we have. And they've learned how to override their natural inclinations to have these cognitive biases so that they can treat factual matter more factually. And also probably it's to do with like gathering the right facts and asking the right questions. And so, so these super forecasters have a really great track record of predicting events, sometimes even many years into the future. So they don't know as much about AI as AI experts. But so there's this really interesting study just showing that. So for example, so they defined specifically catastrophic risk of AI as being an event where I can't remember the exact number. Where a very large, like 10% of humans are impacted. Like 10% of humans die in a catastrophic event due to AI. And then extinction is a scenario where fewer than 5,000 people remain on the planet. And then, so the domain experts, the AI experts, think that there's about a 12% chance of catastrophe and a 3% chance of extinction due to AI. Whereas the super forecasters, it's a way smaller. It's a 2% chance for catastrophic risk and like a third of a 1% chance for extinction risk. And so, so I thought that this was an interesting study. I'm sure Jeremy has a lot of thoughts about it.
No, I mean, I think it's a really important kind of bit of meta thinking around this whole problem space, right? We always have to manage our psychology when we look at these sorts of problems. And I think it's a critical piece of the puzzle to put in place. Like, I definitely agree there are a lot of cases where this has happened. I think it's interesting, like the kinds of mistakes that AI people have made historically have tended, though, to like downplay certainly the capabilities of AI systems. So, you look at analogous research where people are predicting by what year will we have what level of capability. And consistently what you see is like people will give median predictions of like 20 years from now, and then it happens like 2 weeks later. And like this literally has happened on like especially math related and coding related exercises. And so like kind of breaking this down into different components, I'd be really curious to see what are the specific ways in which the super forecasters disagree, like the specific arguments that they find kind of suspicious, that they're skeptical of. Because there definitely is a kind of AI doomer person who doesn't quite know why they're upset about the whole AI thing. And they have very generic sounding arguments, many of which I would personally disagree with. But I do think it's the case that like AI risk is an unusually technical thing. The best arguments for it come from a group of people that is so insanely niche. It's like there's literally 200 of them working in like OpenAI and DeepMind and Anthropic. And they do have access to like the cutting edge models and have hands-on experience with them in a way that I suspect super forecasters, even very experienced ones, might struggle to get. But I think it's a very valid point. Like we've got to mind the meta psychology. Like I might be actually I might be curious about the sample as well of AI researchers that they polled, because 12% actually sounds very low to me compared to what I hear when I talk to people at Anthropic and OpenAI and DeepMind. You'll hear people there who have estimates on the order of 50 or even 80%. Maybe that's even more to the point that's being made in this article, that in fact, they're so like completely immersed in this area that they've lost themselves. I find the evidence compelling personally, but that doesn't at all do anything for this argument, which I think is very valid and interesting.
Yeah. And so a few key things here is that this is a median estimate. So there could be some people with those 50s and 80s in there. So this is just the median. And then also I should have mentioned that this is specifically the probability of this event occurring by 2100. By the year 2100. And so just to give those other bits of detail. And then for a lot of those questions that you're asking, Jeremy, I haven't dug into the actual paper. So if people want to get into it, it's Karger et al. And it's Forecasting Existential Risks, Evidence from a Long Run Forecasting Tournament. And yeah, so the interesting thing is, so talking about this as a forecasting tournament, so they're now trying to break this into like smaller steps where we're predicting like AI related risks,
Nice.
That we can look into just a few years from now and to see how the super forecasters perform against the AI experts. So some of your questions might be answered around that. And then one final point that I want to make sure we get in there before we move on to the next topic is that so because this is an AI podcast, all I've talked about is the AI risks, the AI catastrophe risks or AI extinction risks. But this study extended to other areas as well. So nuclear risks, engineered pathogens, natural pathogens, and non-anthropogenic causes of catastrophe or extinction. So that could be like a meteor hitting Earth or a volcano or something. And a really interesting thing is that across both the super forecasters and the domain experts, by far, the biggest extinction risk of all of those was AI.
Yay! So that, by the way, that I think is just weird, because I think it's actually difficult to make an argument that we're not going to be dealing with like super engineered pathogens that could wipe out basically a large chunk of life on Earth within the next 5 years. Like, I think it's really difficult to be like 97% sure that that is going to be the case, given what we've seen in AI so far. Like, if you just listen to this podcast alone, where you're like, okay, like we're creating designer proteins, we're like 50xing overnight, like the efficiency of like protein generation and so on. You stack those things up along with any number of other things we've seen in the last like 10 years, say 3 years. And like, I think it's quite plausible, like on the order of like 20% surely, that someone, like I wouldn't bet against like someone in the next at least 10 years putting together a crazy pathogen. Like, we have the COVID scenario that happened. We have all the tech that's coming off the line. It's like, I just like generally, I'm surprised by those numbers.
I think that's another thing that is a good finding from this paper is they don't just include the median, they also have the uncertainty bounds, right? And one note about AI is that they have pretty wide uncertainty bounds. So like for AI catastrophe, the domain experts vary from 4% to 18.5, and the median is 12. So you end up with this wide variety where people aren't really certain. With nuclear catastrophe, even with engineered pathogens, that's something that's been possible for a while and is conceivable. With AI, we just really, there's many questions that we just cannot know. So I think that is something that I find also quite agreeable personally. And with that, fun topic out of the way, as we usually talk about human extinction, let's go back to the present. We have the story, China finalizes first of its kind rules governing generative AI services like ChatGPT. That's pretty much the story. There's now rules. This article notes that if a generative AI service generates illegal content, the provider must take measures to stop generating, improve the algorithm, and report the material to the relevant authority. Seems like, again, China is moving pretty fast on regulating and ruling on this. This is from the Cyberspace Administration of China, and this law will come into effect on August 15th.
So mark your calendars, folks. August 15th, new regs. It's interesting that there's this argument, tying this back to existential risk and all that good stuff. There's been this argument that like, hey, maybe the commies in China, because they're cracking down so hard on, freedom of speech and all these fun things, like they cannot allow companies to just pump out random stuff in chatbots that talk about the Tiananmen Square massacre or any number of other, the Uyghur Muslim atrocities and all that. And so they're kind of forced to solve some important parts of the alignment problem, like just to guarantee that this sort of thing doesn't happen and slip through. And it's sort of an open question as to how feasible a lot of these restrictions are going to be for companies. Right now, these regulations apply to private companies. Notably, they do not apply to the government building its own AI systems. So like, pretty consistent with the way China seems to like to do things. So one set of rules for the private sector and another one for government. Anyway, kind of interesting. People will have to get a license to operate generative AI services. Certainly something that we've heard talked about, in the West when Sam Altman pushed for licensing regimes for generative AI here. All kind of interesting stuff.
Yeah, and illegal, of course, does also apply that, there is censorship. So this is a form of censorship. It also says that generative AI services must adhere to the core values of socialism. So kind of tracks to what you might expect, I guess. On to the lightning round. First, we have 27% of jobs at high risk from AI revolution, says OECD. So yet another survey about the economic impact of AI. In this case, it says that jobs at the highest risk for automation make up 27% of the labor force on average, with Eastern European countries most exposed. Yeah, it kind of tracks with a lot of other predictions. There's a wide spectrum of them, and it's kind of hard to say, but the clear outcome is a large proportion, like 27%, is still a lot of jobs. And this is another kind of data point in that, I guess.
And then we have US senators to get classified White House briefing Tuesday. Now, Tuesday was actually like a little while ago. But they've now received this briefing. It was organized by Chuck Schumer, who is the Senate Democratic leader, and he is kind of low-key famous for being really into this AI stuff. It was done at a SCIF, that's a sensitive compartmented information facility at the US Capitol, so all very kind of quiet and on the down low. And the briefers were, among others, the Director of National Intelligence, the Deputy Secretary of Defense, the White House OSTP, the Office of Science and Technology Policy Director, and the National Geospatial Intelligence Agency Director. At least those are the ones we know about. I assume it's possible there may have been others. And yeah, Schumer's really been all in on what he calls comprehensive legislation to deal with AI. He wants to find different ways to accelerate the legislative process around AI. That's been a big theme for him. He's called out like kind of the slow moving pace of legislation relative to the technology. And so, yeah, this seems like another move in that direction. And he certainly seems to be leading the way.
And speaking of the U.S. government, the next story is that U.S. FTC, the Federal Trade Commission, opens investigation into OpenAI. So this is an investigation based on claims on violating consumer protection laws and putting personal reputations and data at risk. The FTC has demanded records from OpenAI regarding how it addresses these risks, in particular, generating false and misleading statements about individuals. I'm not sure how much of a big deal this is. This seems, probably maybe inevitable given the impact. The CEO of OpenAI stated that the company will cooperate with the FTC, and of course, emphasized that this is, not supposed to happen to people. And now, if you ask ChatGPT, I think it has been trained to say that, I may say wrong things. I can't comment on particular individuals. So this is one of those things we've also discussed. I think having a lawsuit for libel about ChatGPT. So this is very much touching on that kind of aspect of it.
Yeah, I think just one last kind of context note too. So under Lina Khan, who's the new head of the FTC, I believe that they're now 0 for 4 on big tech antitrust cases. They recently had this attempt to block a Microsoft Activision acquisition, and so it's just sort of starting to look a little rough for the FTC right now. Maybe they're biting off more than they can chew with some of these proceedings, but hard to know.
And last up, we have UK universities drop guiding principles on generative AI. So these are 24 universities. They're Russell Group Research Intensive universities, and they have signed up on this code with 5 principles. So the 5 guiding principles say that the university will support both students and staff to become AI literate. Staff should be equipped to help students to use generative AI tools appropriately. The sector will adapt teaching and assessment to incorporate the ethical use of AI, ensured equal access to it. Universities will ensure academic integrity is upheld and share best practices as the technology evolves. So it doesn't seem super specific, but I guess it's good to have a general direction to head in. And some of these, are kind of interesting, such as incorporating education on the ethical use of AI and ensuring access to it. Okay, and we are running a bit over, so we're going to finish up quick. The last section is synthetic media and art. And the big story here is that the SAG-AFTRA union of actors is on strike. And there's been a bunch of coverage. One of these stories is producers allegedly sought rights to replicate extras using AI forever for just $200. There's also another kind of overview article that says that Hollywood's groundbreaking AI proposal for actors sounds like a nightmare. So the proposal is saying that AI should scan background actors and own their likeness for any project in perpetuity without consent or compensation. Now there's, the labor union SAG-AFTRA has joined the Writers Guild of America on strike just last week. So it's a big deal. It's ongoing, and there's a lot of negotiation about this AI component, of course, of scanning and using people's likeness. Unfortunately, we don't have time to get super into it, but I'm sure this will be a story that develops and will have a lot more coverage in the coming weeks. So, John, how was it? Do you still like a podcast, having co-hosted it?
Having seen how the sausage is made.
It was really awesome. I don't know what I'm going to do when this episode comes out now in a couple of days, and I guess I'll listen to it.
I guess you won't be listening to the show. That's funny.
Yeah, no, it's been amazing. I really appreciate you guys taking the time to have me on the show. I know that there's a little bit of extra process getting me looped in, and then thanks to the listeners for listening to my bits, and I might have extended the show a little bit as well, but hopefully you found it interesting. So thanks listeners, and thanks Andre and Jeremy for giving me this great opportunity.
Yeah, thanks John. It was super fun. And as you said, thank you to listeners for tuning in. As always, please share and review and subscribe, and keep tuning in.